Introducing BreakThrough.
Okay, so this is our second game. We are going to be creating BreakThrough. As usual, when you create a new game, make sure you create it in GameMaker language and be careful of where you place it. You should be storing yours in your GameMaker folder within your OneDrive or Dropbox. That is your choice. So I'm placing mine here. Again, when you create your game, make sure that you are naming it as P, whatever your period is. I'm going to put 9, your last name, your first name, and this will be BreakThrough. All right. So most of this game we're going to create from scratch. We are going to use some sound assets a little later in the game, but for now, we're just going to start creating. We are going to create 3 sprites. Right-click, create a sprite, calling this brick. We're going to change the size of this brick, and I want this brick to be rectangular. So we're unchecking maintain aspect ratio and changing the height of this brick to 16 and the width of the brick to 32. Then we will edit. We are going to draw this brick as a solid rectangle with an outline. We want that rectangle to be filled with white and outlined with black. So if you leave your left mouse white and your right mouse black, you will right click from corner to corner. And if you would rather left click, you can switch these so the left mouse is black and the right mouse is filled. Just remember, whichever mouse you're clicking with, that's going to be your outline, and the other will be your fill. The last thing we're going to do to this sprite is change its origin. By default, the origin is in the top left corner. We've discussed that. We're going to change that origin to middle center. And the reason for that will be apparent a little bit later in our program, but I guarantee you, if you don't do this, the code will not work out. Done with that sprite, create a second sprite. This one I'm going to call ball. I am going to change its size to a 16 by 16 square. So I just need to type 16 in either the width or the height. When you click out, they will both update as long as you have left maintain aspect ratio checked. Click apply, go into edit. This time I want a circle, so I'm going to choose top and bottom of the ellipse tool. Again, holding the shift key so you can select the top and the bottom. I want the outline to be black, and I want the fill to be yellow, so I'm going to right click on yellow to change my right mouse color. I'm going to click in the top corner, drag down to the bottom corner to fill that entire 16 by 16 square with a relatively round yellow sphere. Close that. Again, change the origin to middle center, and we're finished with ball. One more sprite, create sprite, this time calling this paddle. Changing its size, again rectangular, so uncheck, maintain aspect ratio. We're going to leave the width 64, set the height to 16, click apply, go into edit. This time I want a white outline and a green fill. I don't care which green you choose, there are lots of them. Choose the one that you like best. I don't care for that one, but I'll go with this one. I'm going to zoom out just a little bit to make sure I get in the top corner. Holding shift to get the top and bottom of my rectangle tool. And there is my paddle. And also changing that origin to middle center. Now we have 3 sprites. We need 3 objects to go along with them. Just make sure that you select the right sprite and you name your object starting with OBJ. Remember that all objects should start with a lowercase obj. Always lowercase. So I have my 3 sprites. I have 3 objects to go along with them. We are going to now move to our room. We have 1 room given to us by default. We're going to change the size of that room to 640 by 480. We're going to rename that room. I'm going to right click, choose rename, and name it level 1. We have a background layer given to us and an instance layer given to us. We're going to rename that instance layer bricks. And we are going to place bricks in this. Now remember that our brick sprite is 32 by 16. Our current grid size is 32 by 32. We're going to change this to 32 by 16 so that we can easily add bricks. I'm going to zoom in a little bit, make that a little bigger. And I'm just going to select my brick object, hold my Alt key, and draw some bricks. Now, when you draw your bricks, they are going to be placed at the intersection of each grid line, not inside the grid cells. And that is because our origin has been set to middle center instead of top left corner. I don't really care what your arrangement looks like at this point. You're going to go and change that up later. So for now, I just need some bricks. Good enough. Then we're going to add another instance layer. I'm going to call this paddle and ball. And I'm going to put my paddle. Oops. My paddle and my ball on this layer. This layer, I haven't changed the grid size. That's why I can't get the ball to go directly onto the paddle. Now I've changed the grid size to a height of 16, so I can set my ball directly on my paddle. Notice I've left some space underneath of my paddle, and there is a reason for that. If you haven't, it's no big deal. We can always move it later. So now we can run our game. Let's see what it looks like. And it's pretty boring. It doesn't really do much. We don't have any code on anything. We have some bricks. They're all white and boring. We have a paddle and we have a ball, but we can't do anything because we haven't added any code. So the first thing we're going to do is add some code to our brick object. So we're going to open our brick object, and we're going to add a create event. And in our create event, we are going to choose a random color for our brick, and we're going to select from a list. We're going to use a built-in variable called image blend, which I'm choosing from my drop-down list. Always choose from your drop-down list. That will prevent you from having typos. Then we're going to use a method or function called choose that allows us to choose one of a list of things. That list could be numbers, it could be shapes, it could be colors, it could be pretty much anything as long as what you're assigning it into is of the right type. So image blend requires a color, and there are a bunch of built-in colors that we can choose from. And what I want you to do is to choose at least 8 colors from this list. Avoid black, and if you're going to use gray or silver, choose one of those, but not both of them, because they are terribly similar. And your colors won't look as random. So I'm just typing C underscore to get my list to come down and choose at least 8 colors. I think I have more than 8 colors, which is fine. However many colors you have, you can choose more than 8 if you would like, but regardless, your list must end in a close parenthesis and a semicolon. Now, I'm going to move these down so that you can see my list a little bit easier. It is possible to write your parameters on separate lines. Not required, but possible. Here I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9 colors. You're required to have a minimum of 8. My choose function has a parameter list that starts with an open parenthesis and ends with a closed parenthesis. Remember, these are called parameters. This is a parameter list. Parameters are the data that you're passing to the function. This is the data the function needs to use. Choose is a function that requires a list of things that are all of the same type. So these are all colors. You couldn't put a color and a number and a object and a whatever in it. But you could either put a list of numbers, a list of values, a list of strings, a list of whatever. This happens to be a list of colors because image blend requires that we assign a color to it. So this is the variable that we're assigning to. This is the function we're using to select a value that we will assign to that image variable. So we're going to select a value and assign it using the assignment operator to the variable that's on the left. The variable is always on the left of an assignment statement. The value you're choosing is always on the right. Our parameter list always starts with an open parenthesis, ends with a closed parenthesis, and the statement finally ends with a semicolon. So now if we run this, we'll get a different view. Now our bricks are not boring white. They have been chosen from my list of 9 possible colors. Notice that there is a hole here in the middle that is black. That is not a black brick. That actually is a hole that I left, which is why we're not using black as one of our brick colors, because our background is black and that would be too confusing. So that is all we're going to do to brick. Now we're going to move on to paddle. Our paddle object needs to move back and forth using the left and right arrow keys. And this time we're also going to use A and D as left and right, so that our user can choose to use the arrows if they want to, or the letters if they prefer to do that. First, we're going to start with a create event. And in our create event, we are going to set some variables. And for now, we have one variable we're going to call SPD. I'm going to set that equal to 7. and this will be the speed of the paddle. And then we'll come back to our paddle object and add another event. You should be able to do these events on your own. So if you would like to pause, you're going to add a key down event for left, right, A, and D. At the very least, you should be able to do left and right. We can talk about how to do A and D quickly if you want to do left and right. Pause now. So for the left, I'm choosing key down, left. And what we're doing is move left. And to move left, we're going to set X. We're going to start with X. We're going to subtract from X our speed variable. Remember that minus equals is the same thing as writing X equals X minus speed. To me, this is more trouble than it's worth when I can write it shorter with this little shortcut. So that's what I prefer to use. You can choose whichever you like. I tend to duplicate events. So I'm going to duplicate my key down to right. Then I need to change this to addition and this to right. Always update both your comment and your code. Then I'm going to come back here. I'm going to right click on left, duplicate this event to key down letters A, and it's done because left and A are identical. So we have our code in left and we have our code in A, and they are identical. We're also going to duplicate right, duplicate event, key down, letters, D, and now this is done because right and D are identical. Here's my key down right, here's my key down D, identical. All right, so now if we run it, we need to test the left arrow and right arrow, right arrow, the A and D keys. Just make sure that you're moving in the correct directions, and we're good. Ball's not moving, but we're not worrying about that right now. One problem we do have is we can move this all the way off the screen, both left and right, which we do not want to allow. So again, there are lots of ways we could fix this, but the easiest, in my opinion, is to create a new sprite, call it boundary, edit it, fill it with some color, not black, and close that. It really doesn't matter where the origin is on this, and it also doesn't matter what the size of it is. So I'm just going to leave that. I'm going to create an object for boundary. I'm going to use my boundary sprite. Then in my room, I'm going to create a new layer called boundaries. I'm going to drag it down. Not that it really matters here, but I like my boundaries layers to be above my background. I'm going to, with my boundary layer selected, pull a boundary object over, select it, drag it down to the height of my room. I'm just going to copy and paste it and then move this one over here so that my boundaries run the entire length left and right of my room. We're not worrying about the top and bottom right now. We are going to treat those differently. So, oh, but look at that. That didn't work out. So what did I forget to do? Well, I created my sprite. I created my object. I put them in my room. but we did not create a collision event. Very common mistake, which is why you always test everything. So we need to add a collision event with our boundary. And for our previous game, in order to make our objects stop at the boundaries, we set x equal to x previous and y equal to y previous. We don't actually need to worry about y. Since we're not moving up and down, we're only moving left and right, x is the only value we need to worry about. We're just going to back that up one step by setting x equal to x previous. It won't make any difference whether we've approached the left side of the room or the right side of the room. X previous is still just backing up one step, not concerned about direction. So now we'll test that. And we stop. And we stop. Now, if for some reason yours still does not work, does not stop at the edges, occasionally I've had students with hitbox issues. So you should open your paddle, expand your collision mask, and make sure that it covers the entire image. If it doesn't, change this to manual and drag your hitbox to cover the entire image. Mine happens to be fine. Also, you might want to check the hitbox on your boundary. I'm not sure why. Sometimes students have issues with this, but the collision box ends up just being a small black square in the top corner that you then have to drag down. I'm not sure what's causing that. But if you have that issue, that's always the first place that you should look. Okay, so that is where we ended on day 1. Then on our second day, we will continue from there. So we are going to work on a few things. Mostly we're going to work on ball. We want our ball. Let's run our game. Let's talk about what we want the ball to do. Right now, we have the paddle moving left and right. I would like for the ball to move with my paddle in the beginning so that I could, as a user, decide where I want to start from. So if I wanted to start from over here on the right because I had a bunch of bricks over there or whatever reason, I could move my paddle and my ball to the right before I start. Then, in order to start, I'm going to use the space bar. So I would want to hit the space bar to make my ball start moving. Once my ball is moving, I'm going to want it to bounce off of the bricks and destroy them as it does. I'm going to want it to bounce off of the sides, bounce off of the paddle, and we'll talk about the top. We'll talk about that a little bit later. So let's just get this much working. All right, so in our ball, we're going to need a create event. And again, in our create event, we're going to set some variables. One variable we're going to use, we're going to call go, and this will be a Boolean variable, which will hold the word true or false. We're going to set go to false to begin with, because we are not moving. So are we moving? No, we're not. So we're going to set moving to false or go to false. We're also going to set a speed variable for our ball. We're going to set our ball a little bit slower than our paddle. I'm going to set it to 3. And this will be the ball's speed. Okay, so there's my creation code for the ball object. We have a Boolean variable called go that we've set to false because we're not going anywhere at the beginning of the game. And we set our speed to 3. Then we're going to add event, and we're going to make this a step event. Step, step. Now, we talked about step events in the past also. A step event is an event that fires 60 times each second. The step event is used to make subtle changes to an object 60 times a second. So this step event is going to listen for instructions. Close enough. And what we're going to do in this step event is make sure that the ball constantly moves with the paddle. So I want the ball to move with the paddle as long as we have not already started the game. So first we need to check to see if gameplay is started. And gameplay is going to be started using that go variable. So a check is an if statement, and I'm going to either write if go equal equal false. Two equal signs is a question of equality. A single equal sign is assignment. We're not trying to assign false to go here. We're just asking, does go hold false or does go hold true? You can write it this way. I don't typically write it this way. Go is a Boolean variable. So if I write if go, this is a question of does go hold the word true? If I write if not go, remember the exclamation point means not. If not go, this is asking, does go hold false? And that is what I want to ask. Does go hold false? If go holds false, that means that we haven't started yet. That means that we want our ball to move with our paddle. So all we're dealing with here again is X, left and right movement. So I'm going to set my ball's X value equal to my paddle's X value. Now, to do that, we've used a dot operator. This period, also called a dot operator. A dot operator is used for extracting data from an object. I have an object called obj_paddle. That paddle has an X value. I would like to use that same X value as the X value in my ball. Since this method, this step method, belongs to my obj_ball, that X is representing the X value of the ball, and this X is representing the X value of the paddle. So now, when I run my game, my ball's X value will constantly remain the same as my paddle until I release it. Another thing I want to point out, notice that the ball is dead center on my paddle. That's not just because I happen to place it that way, because if I didn't place it that way, it would jump to center. The reason it jumps to center is because the origin of the ball and the origin of the paddle are both middle center. So when you line up the X value of the ball with the X value of the paddle, they are centered over each other. If we had left our origin at top left, the ball would always jump to the left side of the paddle, again, making this a little bit awkward. So that is one of the reasons that we are moving our origins to middle center. Okay, so the next thing we need to do is to get the ball to release when we hit the space bar. So I'll go back to my ball object and I'll add another event. This time, the event is going to be a key pressed event, not a key down event, because we're only going to have this happen one time as soon as we hit the space bar. So we're choosing key pressed, and we're choosing space. So when we hit the space bar, we are going to start the ball moving. And what we're going to do is a few things. One, we need to change go to true because we have released the ball. We're going to set our ball's speed equal to our speed variable. I need to pause that. First, we need to make sure the ball is not already moving. Because if the ball was already moving, then we don't really want hitting the space bar to do anything. So we're going to check to see if not go, if we're not already moving. Remember, this is asking, does go hold? False. And if that's true, if go holds false, then we're going to release the ball in a specific direction. So one, we're going to set go equal to true because we will have released the ball. So now we want go to equal true so that the next time we look at this if statement, it will not fire. When we release the ball, we're going to release the ball in a specific direction. What you need to understand is that direction in GameMaker is very specific. So pointing straight to the right is the direction 0. Pointing straight up at a 90-degree angle is 90 degrees. Pointing straight to the left is 180. Straight down is 270, and 360 and 0 are the same thing. So we want to only focus on moving our ball up. So you might think between 0 and 180. However, we don't ever want to release the ball so that it goes straight to the right or straight to the left. We want it to go up, but not always straight up. So we're going to release this ball in a random direction. So we're going to get a random direction. And we want that direction to be between 45 and 135 degrees. Didn't have my nums lock on there. 45, still don't. 45 and 135 degrees. In order to do that, we're going to use something called a random number generator. And we're going to set that random number to direction. Direction, turning green, is a built-in variable that every object that is moving is going in a specific direction. So that direction variable, we want to determine that direction variable and set it equal to this random range. So we're going to choose between a random range. And we want that random range to be between 45 degrees and 135 degrees. Now, random range is an inclusive function. That means we could get numbers that include both ends, 45 or 135, or anything in between them. Some random functions are exclusive. So you have to make sure that you understand the difference between inclusive and exclusive. An inclusive function means these numbers are included. So I could get 45, I could get 135, and I could get anything in between there. So that's going to always go up, but not always straight up. So we're going to set our direction to one of those random numbers. We're going to set our speed, also a built-in variable, to the speed that we've set in our create event, which we have currently set to 3. And then we're going to end our if statement here. So remember that an if statement that has more than one line of code in it requires an open and close curly brace. Those are curly braces, not square brackets and not parentheses. Our if condition does go inside of an open and close parenthesis set. And we did use square brackets when we were dealing with alarms. So inside of our if condition, assuming go holds the word false and not true, we're going to change go to true. We're going to grab a random number between 45 and 135 and set that to our direction. That will determine what direction the ball moves in. We're going to set our ball speed to what we have set in our user-defined variable, SPD. Remember that direction and speed are built-in variables that are provided by GameMaker. So now when we hit the space bar, remember this is in our key press space, when we hit the space bar, our ball is going to move. So let's just check that out. So now my ball stays with my paddle until I hit the space bar, and then when I hit the space bar, it will start to go up. Now, my ball went all the way outside of my room, which is a problem. But we can fix that by adding some collision events. Now, we actually need a few collision events. I need my ball to collide with my boundary. I need my ball to collide with my bricks. And I need my ball to collide with my paddle. So I'm going to go ahead and add 3 different collision events. Let's start with a collision with brick. When we collide with the brick, we want to do a few things. We want to delete the brick and bounce. Now, surprisingly, the order we do this in actually matters. So let's do it correct first, and then I'll show you why it matters. So the first thing we want to do is bounce. But we want to bounce at an angle, and an angle that makes sense depending on the angle that we hit at. If we are moving straight up when we bounce, we should move straight down. If we're moving toward the left when we hit, we should continue to move toward the left when we bounce down. And luckily for us, there is a method that will do this for us. So we're going to type move, bounce, all advanced. Notice that advanced is the parameter inside of our move, bounce, all method. And our advanced parameter is going to be true. Now, why true? Well, it's a little bit confusing to understand why we're putting true in here. So for now, just trust me. We want that to be true, not false. If you'd like to play around with it, have at it. But for now, I'm just going to write true in here. So I'm bouncing true. So let's see what that does for us. When I release my ball, it's going at an angle and it's bouncing at that opposite angle. Now, right now, if you haven't noticed already, every time I run my game, it's being released at exactly the same angle. Every time. Now, I could try and catch the ball, but there is no code to catch the ball. But it is going at the exact same angle every time. We're going to fix that, just not right at the moment. But the other thing we want to have happen is we want to destroy the brick. Now remember, we've done this before. We've destroyed things using instance destroy. And we talked about whether or not we need to put a parameter inside of here. If we put nothing in the parameter list, we leave that parameter list empty, we will get one result. And if we put information in it, we'll get a different result. So the question is, which do we want? So when I release the ball, okay, I know the bounce worked, but now my ball disappeared, and that has to do with this instance destroy. Instance destroy with an empty parameter list will destroy this instance. This instance is the instance that we are currently coding inside of. We are inside of our ball object. We are coding our collision with brick, but we are inside of the ball object. So by leaving that parameter list empty, we are destroying the ball. If we want to destroy what we collided with, well, that is other. This is the object we're in, and other is the object we collided with. So now, when I release the ball, it will destroy the ball, or the brick I ran into, but then the ball goes right through my paddle because I do not have a collision with my paddle yet. So before we move on, let's just look at what happens if I rearrange these. So I'm going to select these two lines of code. I'm going to cut them and move them up so that first I delete the brick and then I bounce at an angle. We run our game. I'll move over because I know what angle I'm moving at. We'll talk about that again in just a second. And oh, look, it deleted multiple bricks. Now the reason is because things are happening very quickly. Remember, there are 60 steps per second, and each step, something is happening in your game. The time that it takes to go from this line of code to this line of code is actually more than one step. That's why we're getting 2, 3, 4, maybe even 5 bricks destroyed by this one line of code. Whereas if we bounce first, and then we delete the brick that we hit, we will only delete the one brick. So make sure that you bounce first and then you destroy what you bounced off of, not the other way around. Okay, so the next thing we're going to talk about is bouncing off of our paddle. So we're going to look at a collision event with paddle. Now I am putting this in the ball because remember the ball is the object that is moving, and we talked about where collision events belong. Collision events typically go into the object that is doing the moving. The ball is colliding with the paddle. The paddle is not technically colliding with the ball, although you might look at it that way because you're forcing the paddle to go over there. But I'm just going to go ahead and put all of these collisions inside a ball. So when my ball hits my paddle, I want it to bounce. And again, I want it to bounce at an angle. So this time, I want it to bounce differently depending on where along that paddle it hits. So if we look at this gray bar as being my paddle, if my ball comes down and hits in the middle, I might want it to just be a perfect bounce. But if I catch it barely with the edge of my paddle, I might want it to bounce differently. So we're going to use a little bit of code in here, and we are going to bounce, but we are going to calculate the bounce, direction, depending on where it hits. Let me make this bigger so you can see it. You're not necessarily going to have to write these comments on multiple lines, but you should have this basic comment. We're going to calculate the bounce direction depending on where it hits. So also I want you to remember that our origin is mid-center. Our origin is mid-center, and that's important where the origin is because these calculations are going to be dependent on the origin being the center of the paddle. So if our origin was the top left, where it is by default, we would get different results from these calculations. So that is another reason we have centered the origin on all of our sprites. We are going to set direction, but this time we're going to use a different method called point direction. Notice that point direction requires 4 parameters, x1, y1, x2, y2. Okay, so what does this mean? x1, y1, x2, y2. Well, the first xy pair, x1, y1, that is the xy location of our paddle. Remember, our paddle is what we have collided with, so that is other.x and other.y. Then I just need an x and a y value. We're just going to write the letters x and y. This is actually the xy coordinates of the ball as we collided with the paddle. So let's just see what that does for us. So I'm going to move my ball over here and let go and see if I can judge that angle. Now, the more I get in the center, the more up and down it is. But if I could catch it on the edge, it's going to go off to the side. So if you get that ball to hit in the center of your paddle, it's going to go mostly straight back up. But if you can get the ball to hit on the corner of your paddle, it's going to give it a little boost off to the edge. On this corner, it's going to go off to the right. On the left corner, it's going to go off to the left. So it kind of allows you to push almost your ball in a specific direction. So that's what I want it to look like. Just make sure that you've ended it with a semicolon. So we have other.x, other.y, and then just xy for our vector locations. And that will be set into direction. Then the last collision we need our ball to make is with the sides. So I'm going to add a collision with the boundaries. Now, these are only placed, we've only placed these boundaries on the left and right side. So this is when our ball collides with the side. We are going to bounce off the side. We'll talk about what we want to have happen off the top and bottom a little bit later, but for now, we're just looking at what should happen as our ball bounces off the left side or off the right side. And basically, I just want to change its direction to the opposite of what it's currently moving. So if we're moving to the left, we'll make it move to the right. And if we're moving to the right, we'll make it move to the left. Basically, all we need to do is change its horizontal speed to the opposite of what it currently is. We're not going to affect its vertical speed. Every object has multiple speed variables. Speed, S-P-E-E-D, is a built-in variable that's really generic. Every object that is moving also has a horizontal speed and a vertical speed. Now, if our ball is moving up to the left, when it bounces, we still want it to be going up, but to the right. So I don't want to change its vertical speed. I only want to change its horizontal speed, and I just want to change it to its opposite. The horizontal speed is called H, S-P-E-E-D, H speed. That is the horizontal speed of my ball, and I'm just going to set that equal to my current H speed times -1. I'm just multiplying it by -1. That will make it the opposite. So if my H speed, if my ball is moving to the left, my speed is negative, say -3. Then when I bounce off of here, I want it to be a +3. Or if it's moving to the right, it's moving a +3. And when I bounce off, I want it to move in a -3. Now we can write it this way, but remember how we've used the plus equals and minus equals? Well, you can also use times equals. So whether you write H speed equals H speed times -1, or you write H speed times equals -1, these two statements are identical. Do not have both of them. If you put both of them, you're going to take the opposite of the opposite, and you're going to be going right back into the same direction. So we are going to change direction to the opposite. By multiplying our current horizontal speed by -1. Now let's see what happens. So this time, instead of moving my ball over to the right so it will hit a brick, I'm going to move it over to the left because I know what direction it's going to go in, and make sure that it bounces properly. And we'll continue to try and get it to go off to the opposite side and see if it bounces there. Yes, it does. Always make sure that you do a thorough test of every little change you make. We've changed our horizontal speed so it will bounce off of both sides. So always make sure that you test both sides. Otherwise, you're likely to be rudely surprised. All right, so what we've done so far, let's just recap. we have gotten our paddle to stop at the left and right sides so that we don't go off the screen. We've fixed our ball so that as long as we have not hit the space bar, our ball travels with our paddle. We've fixed it so that when we hit the space bar, our ball goes up at an angle, and when we collide with bricks, it destroys them. Oh, but we haven't done anything about the top. Now you might think, why do we need to have something different? So if we used the same boundary on the top as we've used on the sides, then we collide with that boundary, it's going to change our horizontal speed, which is going to be a little odd. Let's just look and see what happens. So I'm going to move this down. I'm going to, on my boundaries layer, add another same boundary, select it, stretch it, and on my bricks layer, I'm just going to get rid of a bunch of these. In fact, I'm going to get rid of all of them. So I have selected the top one. I'll scroll down here to the bottom and shift, select that one, and then just hit delete to get rid of everything so that all we're doing is bouncing around the room. So I'm just going to hit space. We're going to, ooh, that didn't work out so well. Let's try that again. I'm going to run my game. This time, I'm going to move closer to this edge because I know it will bounce off of the left edge properly. But did you see that little catch as it hit the top? Let's watch that again. Watch what happens as it hits the top. You can see it. It changed direction. It changed direction in a horizontal movement, but my vertical movement just kept going right off the room. It isn't that I want to change my horizontal speed when I hit the top. I need to change my vertical speed. If I'm horizontally moving to the right when I hit the top, I want to continue in that horizontal movement, but I want to take the opposite of my vertical movement. So let's go back in here. Let's go back to my boundary. I'm going to delete that. And what I need is another object. So I'm going to create another object. And I'm going to call this object top boundary. I'm going to use the same sprite. I don't really care what the sprite looks like. We're not seeing the boundaries anyhow. But now I have a regular boundary and I have a top boundary. Now you might want to go back and call that side boundary top boundary. And if you do, that's fine. I don't really care, so I'm not going to. But now in my ball object, I'm going to need a second collision. So I'm just going to duplicate this boundary collision. I'm going to duplicate this event as a collision with top boundary. And remember, when you duplicate an event, you get identical code. And this is kind of what I want, almost sort of, but instead of bouncing off the sides, I'm going to bounce off the top. And I am still going to change direction to the opposite, but instead of horizontal speed, I'm now going to change my vertical speed. So whatever my vertical speed currently is, I'm going to go in the opposite direction. But my horizontal speed will not change. Again, if I'm moving to the right when I hit, I want to be moving to the right when I bounce. And if I'm moving to the left when I hit, I want to be moving to the left when I bounce. So my horizontal speed will not change, just my vertical speed. Now let's see. Did I put a boundary in my room? I don't believe I did. No, I did not. So I'm going to put a boundary in my room. I'm going to stretch it. Now, they're the same color, so you have to be careful that you actually have a top boundary up there and regular boundary on the left and right. But as long as you're careful, it doesn't really matter because nobody's going to see the color except you. So again, I took all the bricks out. I'm just going to bounce off the left and now off the top, and then bounce off the top and off the left, and maybe I'll bounce off the right, and yes, off the top. And now this is working exactly how I intended it to work. All right. So now all of that is working. Now I do need to go back and put my bricks back in my room, so it might not have been the best idea to change them, although I really didn't like that arrangement. So I'm just going to let you choose how you want your arrangement to look, and I'm going to go ahead and do this. I'm going to add some bricks, and then I'm going to speed this up a bit. So okay, so I've made this arrangement, and I'd really like to put a brick in the center here, and I can't seem to do that. So here's how you manage it. First, I'm going to turn my grid off. Then I'm going to come over here and place my brick. And you kind of have to eyeball it to get it to place just right. I think it moved up a little too high. Well, maybe not. Okay, then I'll turn my grid back on and make sure that it still looks good. Okay, now I'm happy with it. You get the arrangement that you like. I've got the arrangement that I like. When I run it, we get our colors, and we can play our game. Now we actually have a pretty decent game, except if I, miss or hit my ball with the side of my paddle and cause it to go down, now my game's over. We're going to add one extra little thing that you will be required to have in your game when I test it, just because it makes it easier for me. Okay, so we just need to put this on some location or another. We're going to eventually need something called a controller. So we're going to go ahead and add that controller right now. So we're going to create an object. This object will not have a sprite. Most objects have sprites. Controllers do not. We're going to call this obj_controller. And a controller object is basically what it sounds like. It's an object that will control certain things in our game. This controller, the only thing we're going to add to it right now, we're going to add a key pressed, not a key down, because I don't want it to happen over and over. I just want it to happen once. A key press event using the letter R. Okay, so what we want this event to do is restart the game. And this is actually quite simple to do. Now, if you can't remember the name of this method, I usually just type restart. And there are 3 different restart methods. There's one for a path action, definitely not what we're talking about. There is a game restart and a room restart. For now, we're going to use game restart. So now, to test this, we first need to make sure that our controller gets placed in our room. Controller won't do you any good whatsoever unless you actually use it. we use objects by placing them in the room. I'm going to choose my boundaries layer. I'm going to select my controller object and drag it into the top left corner. Why the top left corner? Well, because that seems to be standard. Every game I've ever looked at that had a controller, the objects are placed in the top left corner. So that's typically where I put mine. If you only have one controller, then you could put that on your boundaries layer. Sometimes you'll have a game that has multiple controllers. So you might have an enemy controller, a player controller, a game controller. And if that's the case, then you'd want a separate layer just for your controllers so you could have them all together. But I have this one controller. Notice that my controller looks like a little circle with a question mark in it. That's not because it's a controller. That's because it doesn't have a sprite. But controllers never have sprites. Typically, if you drag an object into your room and it looks like a dot with a question mark, it's not what you really wanted to have happen, because most objects we do want our user to see. However, the controller is not something the user will ever interact with, so it should not have a sprite. But now I'll run my game, hit the space bar, and if I click R, it'll restart my game. It'll always restart my game at exactly the position it started in. However, notice I am getting different colors of blocks. That's because the color is being chosen randomly every time the bricks are all created. And when we restart the game, the bricks all get recreated. But it is a nice way to be able to test things over and over. So instead of restarting my game every time I miss the ball, I can just click the R to restart, so I don't have to shut down and start it back up again and waste all of that time. Just a very nice debugging tool that I will expect you to use so that I can use it when I test your game. However, remember that when you finish your game, it really should be removed. This is not something you would want your user to be doing. That ends our first week. See you next week.